Hi mathematicians. We are going to be working on a real life application of your linear functions that you've been practicing. In your story today for lesson 2.4, you have a boat rental company and they put out advertisements letting people know that they can rent boats for $9 an hour. But when you actually show up at the boat rental place, they changed the price and they made it an even better deal. And the person who works there is being very mathy about it. So she creates this equation to charge people for the boat rental. So that's the equation you're going to be working with throughout the problem in 2.4. And remember, we're following this format, but they replaced the y with a c and the x with a t. So you have different variables but the same format. Okay, I'm going to walk through an example of how I would think about this problem using a different equation that's kind of similar to yours. Okay, instead of a boat rental company, I'm going to be doing something with a motor. I don't know, something, I'm going to do moped rentals. So they're a little bit more expensive than my little kayaks over here. So for my moped or motorcycle rental company, the cost is equal to 50 cents for every 1 minute that the person rents this vehicle from me. And then I'm going to charge them $6 kind of for safekeeping. So when they walk up and they get the contract from me, I'm going to take $6 from them. And then however long they're out on my little vehicle, I'm going to charge them 50 cents for every minute that they're out there. So let's think about what this would look like on a graph. So my independent variable is my C, because it's dependent on how many minutes I decide to rent my vehicle. So my T is my dependent variable, and my independent variable is my C, so it's going to be arranged like this if I was to graph it. But because I'm starting with $6, that means it's not going to go through 0, 0, the origin of the graph. Instead, it's going to have a y-intercept of 6 in my example. So let's say that 6 is right here, and then my line is going to proceed in a positive direction from my y-intercept of 6. So your graph is already drawn for you in your problem. You just have to try to figure out what the different parts of the graph mean and why it looks the way it looks. So hopefully my graph will help you a little bit on interpreting your graph. Okay, so if I was to take my vehicle out or someone was, for 2 minutes, that means that they would get 50 cents and 50 cents for the minutes, plus the $6. So they would get $1 for the minutes and $6 for the basic cost at the very beginning. So for 2 minutes of rental of my vehicle, that person would pay $7. So 50 cents times 2 minutes plus 6. So my question would be, what would it be if it was 20 minutes or 50 minutes or 37 minutes? So you're going to be working with trying to figure out how much it would cost for specific amounts of time for the next part of this. So I'm going to walk through how I would do 20 minutes for this. So 20 minutes is my time. So that's going to replace my t variable. So I'm going to rewrite the equation with that in mind. So I'm doing this all the same. But where the t is located, I am going to enter the number that it gave me. So I'm going to put a 20. And then plus 6. And now I have to proceed to calculate all those parts and see what I end up with. So half times 20, or half of 20, is 10. So now I have C is equal to 10 plus 6, which I'm sure you can clearly see now the answer is C is equal to 16. So the question was, if I rented my vehicle for 20 minutes, how much would it cost? And the answer is it would cost $16. So the solution to the equation is C equals 16, but the actual answer to the question has to be written with its label with it, which is $16. So that's the actual final correct answer, and this is the process I went through to get there. So sometimes you're going to be asked for the answer to the equation, sometimes you're going to be asked for the answer to the real life application of the problem, which in this case would be $16. Okay, so what if instead of me giving you the t variable, I gave you the c, which is the y variable, and that's what I'm going to show you in this $50 example. So in this one, I'm going to say this person is going going to spend $50. Maybe they got money for their birthday and they're willing to spend up to all of the money they got. And then I'm going to write the rest of the equation that I don't know out exactly as it was. And it'll look like this. Okay, now I have to do the same kind of process, but it's almost backwards. And this one's a lot harder. This is probably the first time you've done these kinds of equations, and you're not expected to know them yet. What you're expected to do is use some strategies that help you figure them out, a little bit of guess and check, a little bit of figuring out. I'm going to go ahead and show you like the shortcut easy way, and if it makes sense to you, use that method. If it doesn't make sense to you, try some guess and check, those kinds of things. I'm technically not even supposed to show you this example. I'm supposed to let you try to figure it out yourself, but we don't have one another to help because we're not working in groups. So I'm going to go ahead and show you an example that will help you. Okay, so right now I have this variable chunk and a number I know, and that's called a known variable or known amount. So I'm going to get rid of what I know on the right-hand side of the equation. So right now it's a plus 6. The opposite of adding 6 is subtracting 6. So I'm going to go ahead and subtract 6 from here. And when I do that, I'll end up with 0. If I subtract 6 on the right-hand side of the equation, I also have to subtract 6 on this side of the equation to make it continue to balance, because equations are kind of like scales and balances. They always have to be equal on each side. So 50 minus 6 would be, I don't even know that. It'd be 44. That's funny. I don't think my brain's working yet. Okay, so I subtracted that. Now I'm going to write the rest of the equation. And this part is gone now because it equaled 0. I don't need any of that. So we are now looking right here. I know there's a lot on my little board. And I'm sorry, it's so crowded. This is a space I have to work on. So hopefully you can follow where it's at. Okay, so now I have half of something is equal to 44. Now, if you think about that backwards, so you want half of some number that equals 44. So that tells us that the number is going to be bigger than 44. Now, you probably already figured out that's 88. Let me show you how that works mathematically to make sure you're being very accurate with your math. Okay, so right now, this is multiplied because 50 cents is pushed up against t, and anytime things are pushed up together, it means multiply. So right now I want to divide. I want to do the opposite to undo it. So I'm going to divide this side by 50 cents, and I have to divide this side by 50 cents. That will give me whatever this side is equal to t, because this is going to go away. So 44 divided in half is the 88 I was thinking. So the original question was, how long can the person go if they have $50 to spend? And they can go 88 minutes, so way over an hour for my vehicle. Okay, I'm going to erase some of this. Erase a lot of it, actually, so that I can work on this inequality up higher so you can see it. So the last thing I want to show you is what's called an inequality. There are lots of signs that you're already familiar with. These two, greater than, less than, and equal to, you're already familiar with those signs. So I don't know if you're familiar with this sign or not, but it just means greater than or equal to and less than or equal to. It's kind of a half equal sign and a half a greater than or less than sign. Okay, so those are called inequalities, and I don't think you've worked with them much. There are some special rules, but right now you're not going to be given special rules, the tricky ones. They're just going to give you some very basic ones, and we're going to work towards the more challenging ones. So basically what we're going to do is just treat that like an equal sign, keep it the same sign it is, but act like it's an equal sign. So the first thing I want to do is the same thing I did last time. Is I want to get rid of, there's a part with a variable, and I want to get rid of the other thing that's the known quantity. So I'm going to subtract 6. I actually think I am going to work down here. When I subtract 6 from that side, I also have to subtract 6 from this side. This equals 0, so it goes away. This is 4. So now I have 50 cents per minute is equal to 4. And I just have to continue, oops, it's not equal to, excuse me. You think of it as equal, but you have to keep it as it is. So now I need to divide each side by 50 cents because right now it's multiplied. I want to do the opposite of multiply, and that is division. So I'm going to divide each side by 50 cents. Okay, this goes away because 50 divided by 50 is 1. So I'm going to be left with a t is less than or equal to whatever 4 divided by half is. And of course that's 8. So the original question with this was, how long can they go if they want to spend less than $10? So their time has to be less than or equal to 8 minutes. They can go 8 minutes, 7 minutes, 6, 5, 4, anything like that, but they can't go 9 minutes for the amount of money they have. Okay, so once again, guess and check is what they want you to use, and you can definitely use that. If these strategies, the actual way that you're supposed to do them helps you and you get it, use them now. If you don't yet, we're going to keep practicing them over and over again. Okay, this is tricky stuff because it has a lot of new material in it, and since you skipped 7th grade, you didn't practice these things very much, but I know you've got the math skills, so we can work together and figure them out. Okay,